Welcome back guys, I'm Umrag and in this video we are going to understand the flow of control in a recursive function with the help of three classic examples. Let's go check it out. So here we begin by the first of our three examples, finding the sum of first n natural numbers. Sounds easy, right? So let's try to write the function using recursion. So guys, as you can see in this video, our main focus is not about writing the code, but to understand how this works. So let's try to write on this logic using a sample input value for n. Let's take the value 4. So what happens after we pass n equal to 4 into the function? First thing we do inside the function is we check whether n is equal to 1. If n is equal to 1, we return 1. But according to our input, n is equal to 4. So we move into the next line. And what do we return? N plus sum of n minus 1. So according to our input, the function will return 4 plus sum of 3. Now see, as 4 is a constant, we let it be and we focus on the function part. Now we have sum of 3. What will it return? In the same way, as 3 is a constant, we let it be first and focus on the function part. In the function, we have the parameter as 2. We check if 2 is equal to 1. 2 is not equal to 1. So we move into the next line and return. So just like the previous step, as 2 is a constant, we let it be and focus on the function part. Here we have parameter as 1. We check if n is equal to 1. 1 is equal to 1, so we return 1 here. Now I request all of you to watch very carefully as the main aspect of recursion begins hereby. As soon as we call the function sum with the parameter 1, it returns only one constant as an output, which is 1. Thereby, we can replace the output with this function call over here. Watch very carefully now. What do we notice next? The function sum, which was passed by the parameter 2, now returns a value which is 3. So we can replace the value 3 with this. Now the function sum, which was passed by the parameter 3, is returning the value 6. So in the same way, we can replace the value 6 by the function call over here. Finally, at last, we see that the function which we initially called with the initial parameter 4 now returns the value 10. So we can replace the value 10 by this function call. Hence we see that 10 is the value which the function sum of 4 returns. I hope that by this example I was able to give you the gist of how recursion works. Let's move to the next example for a little bit more detailed understanding. So in our next example, we are going to use recursion to find the factorial of a natural number n. This problem is served as a classic example in definitions and discussions of recursions. So let's write the function for this. So guys, this problem of finding factorial is almost the same as finding the sum of first n natural numbers, just like the previous problem. Just in this case, we are going to find the product of first n natural numbers instead of sum. Let's do it. We are going to take the value of n as 4. So moving inside the function, at first we check whether n is equal to 1. The value 4 is not equal to 1, hence we move into this line. Here we got one constant as 4. Now let's focus on this function and move into the second step. Here we got the second constant, that is 3. Focusing on the function here, the parameter is 2. We pass 2 into this function. 2 is not equal to 1. We move into the next line. And what do we return? Finally, we get to see another constant, that is 2. We keep hold of it and focus in the function. Here we see that the parameter passed here is 1, which satisfies this condition here. Therefore, the function returns 1 here itself. And finally, giving our last constant as 1. Now, if we are supposed to find the output, we can just find the product of all these constants here. But let me show you how actually this function works. Almost the same as the previous problem, just we are doing product here instead of sum. So as factorial of 1 returns 1, we can replace 1 by the function call. What do we see next? The function factorial 2, which we called earlier, now returns 2. So now we can replace 2 by the function call. What do we see next? The factorial 3, which we called earlier, now returns 6, replacing 6 by the function call here. Finally, we can see that the initial function call of factorial 4 returns the value 24. Therefore, our final output of this entire function call will be 24. So guys, remember that the key to understanding a recursive function is breaking it down until you reach the base condition. Keeping this in mind, we are now moving to our final example. In our third example, we finally ran into the problem of finding the nth term of a Fibonacci series. Let's write the function for this. Compared to the previous example, this one looks far more complex, right? Actually, it's not. Let's dive in by putting the value of n equal to 5 in this function to see how it happens. As we enter the function, we check the value of n, whether it is less than or equal to 1. It is not, and therefore we move into the next line. What do we return here? Fib of n minus 1 plus fib of n minus 2. So according to 5, we should return fib of 4 plus fib of 3. In the previous examples, we saw that we would get a constant here and a function call over here. But in this case, the only difference is we are getting a function call in both the ends, just with the different parameters. So let's start from the right function call. Because our parameter is 3, which is greater than 1, we return fib of 2 plus fib of 1. Focusing on the right side function, we see that the value of n is 1, which satisfies this condition, and hence we will return n, which is 1. Finally, fib of 1 returned a constant 1. Now can you guess what will be returned by fib of 2? Focusing on this function, fib of 0, we see that 0 is lesser than or equal to 1. So we will return 0 here. In the same way, fib of 1 would return 1. So finally we can see that all the function calls in the right side return constants. Now let's move to the left side, fib of 4. I hope now it would be easy for you to guess what would this function return. In the next step, we already know that fib of 2 will return fib of 1 plus fib of 0. And now we can put the corresponding outputs of fib of 1 and fib of 0, which are 1 and 0 respectively. After this, the only function call that is left is fib of 3. Fib of 1 returns 1. And finally, fib of 2 will return fib of 1 plus fib of 0. So at last we need to add all the leaf nodes. Let's see what do we get. Finally, we see that the fifth Fibonacci term is 5, which is the correct answer. So while ending this video, I really hope that all my viewers would be able to understand or debug any programs containing any recursive function in them. Please comment out if you find any mistakes in this video or if you are unable to understand some little points I made. Stay tuned, I'll see you in my next video.